What's up, everybody, and welcome to the YesWelder YouTube channel. I'm Nate Beck, and today we are going to be unpacking, reviewing, and checking out YesWelder's CT2050 multi-process machine. This is a super powerful machine in a really small package that's light, easy to move around, and can do a bunch of different jobs for you. So I just got this unpacked. We're gonna unpack the rest of it and start digging in. All right, so clearly, YesWelder hooks it up when you purchase the CT2050 with all the goods you need to start welding. Now, the foot pedal is an optional add-on. This does not come with the machine. This stuff all does, and let's walk you through all of this stuff right now and its awesome features. So first off, we have the machine itself, the CT2050. It does DC TIG, AC TIG, DC pulse TIG, AC pulse TIG, stick, and plasma cutting. Now, what's awesome about what they did when designing this machine with plasma cutting is, as you can see, I do have an air compressor here, right? But for people that don't have an air compressor, you do need compressed air to plasma cut. However, what YesWelder's done is they actually put a air compressor on the machine itself, so you don't have to run a separate air compressor. Or if you prefer using your own air compressor, you have that option as well. That's one of my favorite things about the CT2050 is that, you know, the flexibility of it, you know, to fit into your shop. YesWelder's not asking you to go purchase other stuff from other people. They're trying to fit into your current setup, which is also why I love why they send you with this too. What this is a 220 to a 110 adapter. So let's say you're running a shop and you don't have 220 or a 240 plug, which is what comes on most all welders. They do send you an adapter so you can run this welder as a 110. You're just gonna plug that in right there. And now you can plug this into just like a regular household outlet. So running down the line here, we have our TIG torch. Now, they don't send you with a pedal because this TIG torch can actually be used with a thumb to increase and decrease amps. So that's the first option. It comes with a plasma cutter. It comes with your stick electrode clamp for stick welding. It comes with your ground clamp used in all processes. You get your argon tube. You get a full setup of TIG, collets, cups, and back caps. You get your oil water separator. This is going to be attached to the back of the machine, which we'll do here in a second. I'll show you how to get that done. And what this is going to do is this aids in the plasma cutting torch process. These are gonna go with your plasma cutter. And then finally you get some tubing to connect all of the connections on the back. Now this is obviously a bit long, so you can cut it to length so you can figure out how exactly long you want it, so it fits, again, your setup. So now that we've kind of gone through all of this, let's start assembling all this stuff and really digging into the CT2050 and all the awesome things it can do. All right, so one of the first things that I like to do when I get any new tool is start with the smallest pieces first, just so you make sure they don't get lost. So with the CT2050, we're gonna install the oil water separator first because it has some of the smallest pieces and it stays on the machine pretty much at all times. So that's just a good thing to knock out of the park from the top. So these are the basic tools you're gonna need to put on the oil water separator. I have a Phillips head screwdriver. I have a set of snips. The snips are just going to be to cut the tubing. I have a small crescent wrench. I have pipe tape that is supplied by YesWelder. I have the oil water separator, the fittings sent by YesWelder, and a Sharpie. So the first things first is I'm going to put some pipe tape on the end of these threads right here on the fittings. Basically what pipe tape does is it ensures that there's no air leakage, because when you have no O-ring, sometimes it's kind of hard to make a airtight seal. So pipe tape is used on a bunch. It's a very, very common thing. They sell it at pretty much any hardware store. However, you don't need to go because YesWelder's got your back. So they got it. So basically you just like rip off a piece and you're gonna take your fitting, line up the pipe tape over the threads, and now we're gonna hold it and now spin your fitting clockwise so the pipe tape lays on in the correct direction, so when you put it into the oil water separator, it doesn't come off. Now you're gonna get a little bit of pipe tape overhang on the surface of the nut where you're gonna put it in, and that's totally fine. So we're gonna have our oil water separator, pipe tape fitting, screw it right in. Now, the oil water separator, these fittings do spin on their own, so you can have more flexibility when running your hose, so that's where our crescent wrench is gonna come in handy. Just tighten that up. And you don't have to hog on it. It just needs to be tight enough where it's not gonna let any air out. Again, pipe tape comes in there. So we've got both of these in. Now we are ready to mount this onto the CT2050. So on the back of the CT2050, you're gonna have a couple different things here. You're gonna have your gas in, gas out, argon gas, and your on and off switch. But all we're worried about right now is gas in, gas out, and these two poles right here. All right, so what we're gonna do first is we're gonna take the screws out of these poles. And this is what the oil water separator is gonna mount to. Now be careful, they're really tiny screws. And you don't wanna lose those. Now the oil water separator is gonna sit in this cradle, also sent by YesWelder. And basically what you're gonna do is you're gonna unscrew this top and mount it in here like that, right? But because of the size of everything, I think it's easier to mount this first and then go back and mount the oil water separator onto that. Just because I think it's just easier, you just get a better angle on everything. This is where the Phillips head screwdriver is going to come in handy. Now this mounting bracket is slotted, so you can slide it kind of back and forth, so it can fit your setup and how you like to get it going. All right, and then we're gonna slide this in from the bottom. Now be careful, this is glass, so you don't want to drop this on your table and shatter that. Slide the top ring down, tighten that up. And now that is good to go right there. All right, so we've got this mounted. Now we have to use the connections, right? So we have gas in, gas out, and all of this tubing. So what I like to do is we're just going to feed the tubing into one side by slipping it in. Yep, give it a little tug, make sure that's connect. And then I'm going to mark it with a Sharpie, like line it up and then mark it with a Sharpie on where I want to make my cut. I keep it. And then we're going to slide that in there. There we go. There's that one. Now we're gonna do the same thing on the other side. Now we're gonna double check connections, make sure everything's nice and tight. We're good to go. All right, so we're here on the back of the machine, and there's a couple different things going on back here that we need to set up prior to using the machine. And the first is this O-ring needs to go on the inside of the argon port in the back. So we're just gonna slip it in there, make sure it's nice and flush. Just like that. All right, and then the second thing is if you have a CNC routing machine, YesWelder has supplied the pin supports to actually connect this machine and the cut capabilities of it to your CNC machine for automated plasma cutting. All right, so we're here at the argon bottle and the regulator. This stuff is not provided with the CT2050. This is very typical welding equipment that you can get at your local welding supply store. And this is your argon tank. Your regulator is going to go into your argon tank, and then your argon hose that's connected, that we just connected to the CT2050, is going to go right up under here and screw in. And then again, we're going to use the same crescent wrench. Hook that up. And again, it doesn't have to be super, super, super tight because we don't want to bust that O-ring in there. But nice and snug is good. Sweet. All right, so now that we've gone over everything that comes with the YesWelder First S CT2050 welding machine, let's go over the machine itself, because like I said, it has a lot of features packed into a small package. Let's go through them all right now. All right, so here we have the front screen of the First S CT2050, and I'm gonna run you down the modes. So right here on the left-hand side, we're gonna have weld mode, and this is how we're gonna choose what mode we're in. Our options are DC TIG, stick, cut compressor, and AC TIG. So starting in DC TIG, this is gonna be your typical TIG. You're gonna be welding mild steel, stainless steel. You're gonna have your amps, and then this is your input voltage. Right now I've plugged into a 240 outlet, so that's what we're running right now. Switch down to stick. In stick, we're gonna have amps, voltage. The VRD and the hot start we will get into when we actually put all the leads on to talk about stick, but they are there in this. We have cut. So this mode is going to be cut with using your own compressor, as we see this illuminated right here. And of course we have our settings, which we will get into again when we start plugging in the cutting leads. Cut with the onboard compressor. Now this needs to be running at least 60 PSI. And AC TIG. AC TIG is going to be, you know, using like aluminum welding, where you're going to have to run electrode positive and electrode negative and have it switch back and forth to get that alternating current. Now with AC TIG, there are two functions you have to also set up, and that's going to be over here. And the first one is going to be the balance. So the balance is going to be the percent of time that the electrode is going to be positive or negative. The higher the number here, the more it's going to be electrode negative. So negative is going to give you a nice tight arc, deep penetration, but poor cleaning. If we go down and we're running maybe like 60% negative, 40% positive, or even less, down to 50% negative and 50% positive, we are going to have a wider arc with better cleaning, but it's also going to have shallower penetration. So the way it was described to me was it's like, you know, start around 70 and then kind of adjust as you go depending on what weld joint you're welding. If you're welding, say like an open corner, it's going to be a bit wider, then, you know, you're going to bring it down a little bit. If you're welding like a nice real tight fit up, then you're going to pump it up a little bit. And that value is going to change depending on what weld you're doing. Now the second one is going to be the frequency, and frequency is measured in hertz. Now, if you have a frequency below 60 hertz, that's going to transfer more energy into the workpiece. It's going to create a wider bead with good penetration. This is going to be good for like if you're trying to do like a build-up weld, like a triple pass, or if you're trying to, maybe you have an open corner and you're trying to ensure that you're getting both lips of the outside of the workpiece, since it's going to be a bit wider of an arc. Now, if you increase the frequency, it's going to narrow the shape of the arc cone, and it's going to increase the arc force. This is going to give you a more stable arc. It's also going to reduce arc wandering, and it's going to provide excellent directional control over the arc, with the downside being if you do have a wide joint that you need welded, it's going to be a little bit difficult to make sure that the arc is wide enough. So again, this is similar to balance in that it's a preference, and you're going to change it depending on what you're actually looking at welding. So the last piece that we have to set up for all TIG processes is going to be our pre-gas and post-gas. Pre-gas is going to be the duration that gas flows out of the TIG torch before the weld is started. Now, this is going to remove any environment that could be hovering above where your workpiece weld is going to be, and it's going to clear it out and make sure that you have 100% argon in that area. You can set it anywhere. 1 to 2 seconds is usually what I like. You don't need to waste gas, but it is important to get that in there. The second one is going to be your post-gas. Your post-gas flow is going to be how long in seconds the gas continues to flow after you've stopped the arc. Now, as a sheet metal welder, I'm typically running on lower amps, so I'm not putting as much heat into the workpiece. My puddles are typically small, so I can run a 3-second post-gas, and that's enough protection by the time the weld puddle cools. If you're running, like, let's say you're cutting welding 3/16, you're gonna need more on the post-gas. This is gonna take, you're running hotter, your puddle's bigger, it's gonna take you longer for that puddle to cool, so it needs longer protection. So moving out of weld mode, we're gonna go into torch mode. 2T and 4T are going to be this, what you see right here. So when you click the button on the YesWelder First S CT2050 torch, you're going to start at an amp setting at whatever you'd like. We're gonna slope up at the rate you'd like. We're then gonna reach our max amps, which you set. We're gonna slope down at the rate you set, and then this is gonna be the stop. This is the end of the weld. How many amps are you running right before you kill the arc? Now, if you do wanna run a foot pedal, so this is similar to more of a traditional TIG welder where you're choosing exactly how many amps you're running at one time. You can go more, you can go less throughout the weld as many times as you'd like. It's completely controlled by you. You're gonna click this middle button over into foot pedal mode. Foot pedal mode is also going to be if you wanna use the thumb wheel on the CT2050 to choose your amps, you're gonna keep it in foot pedal mode there as well. Now heading over to the right side of the control panel, we're gonna go back into AC TIG. And this is really what sets the YesWelder CT2050 apart from other welders, and that's the AC TIG Smart. AC TIG Smart takes a lot of the confusion out of trying to balance so many settings for aluminum welding, and really breaks it down and make it easier for a beginner aluminum welder to start welding and minimize the frustrations. So to work AC TIG Smart, we're gonna start here in weld position. We have flat, that's going to be welding down on like a table surface. Vertical, the weld's gonna be out in front of you, and you're gonna be going up or down. Or overhead, it's gonna be above you. Now the second half of AC TIG Smart is gonna be your thickness. So how thick is the material you're using? 18 gauge, it's setting this up for a flat weld in 18 gauge at 20 amps. 16 gauge, we're increasing to 40 amps. 14, we're gonna kick up to 55, 1/8 inch 95, and 3/16 160. Obviously, the thicker the material, the more amps you need to ensure proper penetration. So YesWelder has taken all of the mysticism out of aluminum welding, TIG Smart. The last feature of the CT2050 is pulse. Pulse is when you're welding, it's a setting so when you're welding some thin material that you don't want to burn through or blow out, it helps control the heat. It's a very useful setting and not all welders have it, so it's an important one to check out when you're looking for purchasing a welder, and this one has it. So to set up pulse, we're gonna hold down this middle button for 5 seconds. We're gonna come into the pulse menu. Pulse is now on. It can be on in DC TIG or AC TIG. The first step to setting up pulse is we're gonna be at our peak current, let's just say 35 amps. We're gonna push the middle button. Now we're gonna be at our low current. So this is gonna be the lower of the two that it's gonna pulse between. We're gonna be at 11 amps. Pulse frequency. How often do you want it to pulse? If we turn the dial to the right, it's gonna be pulsing more frequent. And if we don't try to the left, it's gonna be pulsing less frequent. And the last one is the duty cycle. So at 50, it's gonna be running your high amp 50% of the time and your low amp 50% of the time. If you go to say 75, you're gonna be running your high amp at 75% of the time and your low amp at 25% of the time. Similarly, if you go the other way to say 25, we're gonna be running our high amp 25% of the time and our low amp 75% of the time. So it's a very customizable setting that is available for you on the CT2050. We exit pulse, we hold it down for 5 seconds, and now we're back in a regular weld mode. All right, so let's talk about how to hook up the TIG torch and actually get ready to start welding. So everything on the CT2050 is gonna plug in on the bottom, on the front for the TIG feature. This is gonna be for AC and DC TIG. So we're gonna start with the ground clamp to make sure everything's grounded while we're doing this first. And second, most importantly, we're gonna turn the machine off. It's really important to have the machine off whenever you're switching leads, just for safety reasons, to make sure you don't get electrocuted accidentally, but also for safety reasons. Even though the machine is off, I still like to hook up the ground clamp first. So because we're in TIG, we're running DCEN, which is direct current electrode negative. So that means our tungsten is negative, which means our ground clamp is positive. So we're going to hook this to our metal welding table or our workpiece. And then we're going to put this into this port on the far left and turn it slightly to the right just to lock it in. Next, we are going to hook up our TIG torch. So here we have our TIG torch. And on the other end, we've got a couple different things going on here. So here's the actual electronegative plug. So this is gonna go into this piece right here. But what I want to talk about before that is if you want to use the thumb wheel to change your amps, you're gonna plug in the cord that is attached to this end of your TIG torch. If you prefer to use the foot pedal and you've purchased that from YesWelder, then you're gonna use this cable that came with the foot pedal and plug it into here. I'm gonna use the foot pedal for this demonstration, so I'm gonna plug one end of this into here. And then I'm gonna plug it all the way in and make sure that I spin this screw on top, just to make sure it does not come out during operation. When I go to the other end here, we're gonna plug this into the side of the foot pedal here, and it is notched. So you have to make sure that when you're plugging it in, the notches line up so you don't mess up the pins. Yep, and then again, screw this holder on the top. Again, this is also notched. Everything's notched, so you gotta kind of make sure that's all correct here. And we're gonna spin that to the right. Make sure that's tight. Now lastly, we have the gas hose. So this is gonna be the gas line for argon. And we're gonna flip this open and plug that in here and screw that on. And for this, we will need a small crescent wrench just to make sure there's no gas leakage. I'm gonna tuck in here, grab our small crescent wrench. Tighten this down. All right, and we are ready to now set up our TIG torch on the end. All right, so to set up the actual TIG torch, we're gonna need a few things. We're gonna need the TIG torch, a tungsten that's not supplied with the welder, but YesWelder does sell these. And you're gonna need the kit for the TIG torch. Now, there's an order of operations here, and basically what's happening inside the TIG torch is all the pieces are like pressure fit together that holds your tungsten at the desired stick out you want. So the order that you put everything together is really important. So we're gonna start with this. And this is gonna be screwed in the front. Now, this is all finger tight. There's no tools needed here. And then that's there. Now we can slide our tungsten in that we've already sharpened. And that's gonna come out the front. Then we're gonna take our collet, which is this piece. And these are all different sizes. So this is a 3/32 tungsten. So we have to look at the base of the collet and make sure that it's 3/32. And we're gonna slide this on here. And that's gonna slide down the inside. So it's gonna sit on the inside all the way in. Now for the cups, we're gonna put the cup on the end. This is a number 6. Now they are all different diameters on the end, which allows more gas flow or less gas flow. You want the most amount of gas flow possible, but if you're trying to get into like a cramped place to weld, like maybe you're doing like a really tight T-joint, you can't fit a 6 in there. That's why you would then use a 4, because you can see how much smaller that is. But since we're just gonna use, like 6 is pretty standard, so then we're gonna put that on the end here, screw that on. And lastly, we're gonna put our back cap on. Now, you get 2 different size back caps from YesWelder. The first one is this little tight, tiny one. This is gonna be used again if you're trying to get into cramped positions. However, if you are gonna use this one, you do have to cut your tungsten down because obviously it won't fit a full-size tungsten. So we're gonna take the long one, slide it on here, making sure this O-ring is on our back cap. Screw this in, and this is what actually now pressure fits everything together and holds everything steady. We're gonna keep in mind what we want our stick out at. And we're gonna watch to make sure that doesn't change as we screw in the back cap. This TIG torch now is assembled, and now we're actually ready to weld. All right, so that's how we get the machine ready to TIG weld. Let's talk about how we can switch over to stick and some of the differences between TIG welding and stick welding. So the basis of TIG welding is we have our assembled torch, which we just did, and we have the filler rod. And as you heat the base metal up on your TIG torch and you go along, you put the filler rod into the puddle, and then that's what reinforces the weld and ensures that it's strong and has good penetration. Now with TIG, obviously we need a shielding gas that's gonna come out of our cup, argon, that's gonna protect the weld from any contaminants in the environment. Now, stick welding is a much more basic process, and it's actually an older technology. With stick welding, you have what you call is your stick holder. Some people call it a stinger. And on the inside, you have different slots to slide your electrode in. Now, a stick electrode is actually coated in a flux, and that is what is going to protect the weld, so you don't actually use a gas with stick welding as you do with TIG welding. You just slide your stick electrode into one of the slots, which holds it steady, and now you're good. And you can do a 90 degree, you can do a 45 degree, you can do straight up and down. So it really does let you kind of, play with different angles, what's best, obviously, because it's going to be a little more difficult to get in, like with TIG, you can kind of like adjust where you're going with the filler rod. With stick, since it's all one piece, you have to use the stinger's options on the angle. So let's go over how to now switch the YesWelder CT2050 over from TIG to stick. All right, so we're here at the machine. It's currently set up for TIG welding, and we're gonna set it up for stick. So the first thing we're gonna do is turn off the machine. I'm gonna take our TIG torch out. I'm gonna disconnect the foot pedal. I'm going to disconnect the argon hose. It's really important that when you're running a certain process, whether it be TIG, whether it be stick, whether it be cutting on the CT2050, that only the leads you need for that process are connected to the machine. If you leave other leads connected while you're doing a different process, it may damage the machine. So it's really important to take all the leads off, put on the leads you need for the process you're gonna run, and then continue on. All right, now one thing I have to be cognizant of before we put the TIG stuff away and switch over to stick is that when we're storing this, the cup is made of ceramic. Cups can also be made of glass, but the ones most commonly made of ceramic, so this can break. So when we store this, we want to be really careful about where this goes. All right, so with that, let's set up for stick. So for stick welding, it's run DCEP. Direct current electrode positive. You can run stick in DCEN, direct current electrode negative. However, you're generally gonna get pretty poor penetration and the weld will be a lot weaker. So we need to change our ground over to the negative side, turn it to the right, and then we're gonna take our stinger and we're gonna connect it to the positive side. And that's it. Like I said, stick doesn't run any gas, so we are good here just like this, and we can turn the machine back on. All right, now that we've got the machine back on, we are running in DC TIG right now. So to get to stick, I'm gonna push the weld mode button and click down to stick. Now we have our amps. Again, I'm running 240 volts, and we have this little thing called VRD, and we have hot start. Now VRD is going to be similar to like a scratch start TIG. When I put the stinger and the stick rod together, now this is live, so any metal this touches is going to spark and start an arc. So and it can be potentially really dangerous. So what the VRD does is that when you're not welding, it's gonna actually lower the current from 131 amps way down. That way, if I accidentally touch this on some metal, I can't get electrocuted as badly as if this was running 131 amps live right now. Because of the differences of the size of the rod, YesWelder has added a function called arc force. Now, arc force you're gonna set to your preference. This is a preference thing, so you're gonna have to test it out a little bit before you figure out what exactly you like. But the basic is, if you set the arc force too high, this is going to, your drop and your actual rod is gonna melt at a higher rate, but it can cause excessive spatter. If your arc force is too low, you're gonna get a lot of soft arc. It's not gonna be a very well defined arc. So you really have to test, figure out what you like, and the number's gonna change for every rod diameter. So playing around with your arc force knob, which is accessible by pushing the middle button in, is really going to be a personal preference thing and what you find works best for you and the size rod you are using. Now the second feature they have on the YesWelder CT2050 for stick welding is the hot start. So a common problem with stick welding is as you actually strike the arc, the stick will stick physically to the metal you're trying to weld. To remedy that, there's a thing called a hot start. And what we're gonna do is push the middle button twice. First one's gonna be for arc force. Second one's gonna go to hot start. We're at 0.5 seconds right now, and that's gonna give the stick a little bit more oomph off the top to just try to prevent that stick and get you into the weld a little bit easier. All right, so that's the basics of setting up the machine for stick. Like I said, stick's a great process. You can use it outside, you can use it in wind. The metal doesn't have to be pristine like it does for TIG. It is a little bit more of an antiquated process with this stick sticking. It's smoky, there's a bit more fumes to deal with, but it's really helpful when you need to weld things in places that you can't maybe bring into an air-controlled shop and TIG weld. Stick is still a great process that's used all the time, and as you can see, it's pretty easy to get going on it, and YesWelder hooked it up with a couple extra features to help you along the way as well. So let's actually now take the stick apart, the leads out, and let's talk about the plasma cut feature of the CT2050. All right, so the last function of the YesWelder CT2050 that we haven't gone over yet is the plasma cutting. Now keep in mind, this plasma cutter can use the onboard air compressor or your own shop air compressor. You can use it manually with a torch, or it is also functional if you have a CNC routing machine. So very versatile, like everything else on the CT2050. But before we actually get it going, we're gonna go over the parts of the torch. All right, so here we have the YesWelder plasma cutting torch disassembled and all the parts laid out. The torch handle, electrode, air diffuser, nozzle, and protection head. If any of these parts get clogged or they get used after a while, they are consumable. You can easily disassemble it like so, and then reassemble it in this order. All right, so now that that's back together, let's go to the machine and learn how to plug it all in. All right, so here at the machine, and I'm gonna show you how to hook up the plasma cutting leads to this, but the most important thing is always the machine is off first before we either connect or disconnect any leads. So this is gonna be our ground clamp. It's gonna go on the far left, on the positive. This is an electronegative process, so that's why our ground is going in the positive. This is gonna be the hose to the plasma cutter. This is gonna go in the same port as the argon hose does for TIG welding. Well, the argon hose for the TIG torch, that is, not the rear. All right. We're gonna use our little crescent wrench to make sure that's nice and tidy. This is gonna be your arc start, and you're gonna unscrew this. Place that right there. Similar to like hooking up a car battery kind of with the terminal. Slide that over, screw that on. And lastly, our trigger control right here. Again, this is notched, so we're gonna make sure the notches line up correctly. There we go. And screw that on. All right, now on the back, we're gonna make sure that our oil water separator is set to 60 PSI and that the argon hose is disconnected from the back. And now we're ready to turn the machine back on. All right, now keep in mind there is cut and cut compressor. If you're gonna use your own air compressor, you're gonna hook that up to the oil water separator in the back, which I'm gonna show you right now. All right, so we're back here at the front. Now let's go over the settings on how to get it all set up properly to make some great plasma cuts. Now, similar to every other process, we have our values that we need to set. So we're gonna do that similar to everything else, pushing the middle button to cycle through. Now we're gonna start here. So this is gonna be the current that the cut starts at. We're gonna hit it one more time, the slope up. This is the amount of time it takes to go from our starting current to our main current. Pushing it one more time, then we're gonna have our main current, keeping in mind this goes all the way up to 45. Now slope down is gonna be the time it takes to go from our main current to our end current, and then we're gonna set our end current and the post gas. Post gas on this is going to, setting too high is gonna waste air, but setting too low, it's not gonna allow your torch to cool down appropriately, and it's going to add a lot of wear and tear on that. So we wanna make sure that that's set at a decent amount. Now that that's set, we are ready to plasma cut. All right, everybody, so that's how you set up the YesWelder CT2050 for AC, DC, TIG, and pulse TIG, stick, and plasma cutting. Now, this is a great package in a little machine that it comes to you at a great price from YesWelder. Quality craftsmanship that's going to allow you to make quality welds and quality plasma cuts. For more information on the CT2050, please visit YesWelder.com. And until next time, enjoy welding with YesWelder.